Hey everybody, welcome back to DentChem. One of the first things you're going to do in class, maybe even at the end of Gen Chem, is learn how to read, understand, and write in skeletal structure. Okay? What skeletal structure allows us to do is quickly abbreviate the two most common atoms in organic chemistry, carbon and hydrogen. We're just going to move slow. We're going to do one atom at a time together, and you can try one on your own. Let's count carbons first. How do I find carbons in skeletal structure? Every notch in the line, and every time a line ends, that means I have a carbon, okay? With one slight exception, which we'll get to shortly. But every time that line either changes direction, there's a notch in the line changing direction, or that line ends, that means I have a carbon. What I'm going to do is I'm going to star each carbon with a red star. So I have a line that ends right here, that's a carbon. I have a notch in the line, carbon. Notch in the line, carbon, and so on. Notch in the line, notch in the line. Each point is changing direction. And it'll also include every time that line ends, I have a carbon. Okay, so right up there, right down there. And now we can see that I have 7 carbons in this structure. Every time that line moves, and every time that line ends, that means I have a carbon. So rather than write out each letter and connect them with lines, I can now put carbons in this structure, easy to read, a tetrahedral form, and there you go. Now let's move on to hydrogens. And we're going to look over here. We see that each neutral carbon, notice I don't have any formal charges on these molecules. What's formal charge? Watch DentChem and find out. I don't have any neutral charge, pluses or minuses, on these two molecules. So I'm assuming that each carbon that I have drawn is neutral carbon, which means it needs to make, you learned in Gen Chem, 4 bonds. Carbon's always going to make 4 bonds. So whatever carbon is making bonds to currently, and it's not fulfilling 4, we just fill in hydrogens so it does. Okay? So if carbon is currently making 2 bonds to other things, well, if it's neutral, it has to make 2 other bonds to something. We assume it's hydrogen. Just because hydrogen is so abundant, we don't even have to draw them in. But we need to understand that they're still there. So let's start down here with this carbon. It's currently making 1 single bond to another carbon. But because it's neutral, it needs to be making 4 bonds. So where are those other 3 bonds going? Hydrogen. 1, 2, 3 hydrogens in there, okay? And we'll just keep moving on that way. And remember, every single carbon here should be making 4 bonds. So whichever ones they're missing currently have to be hydrogen. So carbon's currently making 2, one to carbon below, 1 to carbon up to the left. So the other 2 to make 4 must be hydrogen. This carbon here, 1 carbon bond, 2 carbon bonds, 3 carbon bonds. It's missing 1, so therefore it gets 1 hydrogen. And I got rid of that star. I'm going to put that back so we know it's still a carbon. Same thing down here. I have carbon making 3 bonds. In order to get 4, it needs 1 hydrogen. Carbon making 3 bonds explicitly, so it needs to have 1 hydrogen implicitly. Carbon here on the end is currently making 1 bond. So in order to make 4, it's our job to know that there are 3 hydrogens on it. And same thing up here. This terminal carbon is going to get 3 hydrogens. All right. Now that one little trick, okay, that's not going to always work for looking for carbons, either with notches and looking for the end of a line. Probably the most missed carbon early on in organic chemistry is the alkyne, okay? Alkyne is when the carbon makes a triple bond. So we know here at the end of the line, we have a carbon. We know here that the line changes direction, that's a carbon. And the line ends down here, that's a carbon. Here is the most commonly missed carbon, is our alkyne carbon. Okay, it doesn't really follow our rule of line changing direction because it's linear, and nor is it at the end of the line. But do be familiar with alkyne carbons. Okay, so if you include those with notches and terminal ends, you should be able to locate every carbon for the rest of the year. Pause the video and try this one on your own. First, identify carbons, draw in your hydrogens, and we'll be able to write the formula for this structure down here. All right, hopefully you pause the video, you tried it on your own, and now we can compare answers. First thing we're gonna do is identify carbons. End of a line, carbon. Notch, carbon. Notch, carbon. End of a line, carbon. Notch, carbon. End of a line, carbon. This structure has 6 carbons, so I can say C6. And finally, let's count in our hydrogens. I have a terminal carbon here making 1 bond. It needs to make 4. Where are those other 3 bonds coming from? It should be hydrogen. Okay, 2 bonds already. I need 2 more in hydrogen. 1 bond currently, 3 bonds currently, meaning it needs 1 bond. Gotta have myself there. This carbon down here, it's making 1 bond currently, so 1, 2, 3. Now it's making 4. 3 bonds currently, it needs 1 hydrogen. And our carbon down here at the end is currently making 2 bonds. Okay, that double bond, it needs to have 2 hydrogens on it. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. C6H12 is our chemical formula for that structure there. Okay, that's how you're going to read skeletal structure going forward. Another quick note, even if you have a heteroatom on something, so let's say I have an OH group on this structure, I can count my carbons just the same, end of a line, a notch in the line. I have a heteroatom here, okay? So if I look at this carbon explicitly, it's making 3 bonds explicitly, meaning in order to make 4, there's a hydrogen not drawn in there as well. So it's gonna work. You throw in heteroatoms, don't worry about it, use the same rules. So understanding skeletal structure is gonna help a ton moving forward. And yeah, get a good foundation of it while you can, okay? Also on top of that, last thing, like the video, subscribe to the channel. It's totally free. DentChem is awesome. I hope you think that. Thanks for watching.